Alright, so we're going to do a quick episode on prime factor decomposition, also known as finding the product of its primes. So what does this mean? If we were just to break down this, it would break down as prime referring to a prime number, a factor referring to if you multiply a number to get a multiple. So 3 times 2 is equal to 6. Therefore, 3 and 2 are factors of 6. So it's numbers that multiply into another number. And when you decompose something, okay, it breaks down. So it's basically when you break down into factors that are specifically prime numbers. So let's do 100 as an example. So the method that we use is called a tree diagram. So from 100, what we do is we draw two branches, and in these branches we write down two numbers that multiply to give me 100. So in this case, let's choose any two numbers. Let's do 50 and 2. So when we get to a prime number, if any one of these numbers are prime, we circle it. So in this case, 2 is a prime number. You can't divide 2 any further. So you stop at 2 and you circle it. This tells me, it's a visual representation to tell me that there's no point in me breaking it down any further. I've gone as far as I can, because after 2, I just go to 2 and 1 as factors of 2. So there's no point in writing it down. But 50, I can say 10 and 5, for example. 5 is a prime number, so I circle 5. And 10 can be 5 and 2. And these are both prime numbers. Now, you want to get to a position where you circled all of the branches like these. Okay, you've circled all of them, so you can't actually break it down even any further. So once you've done that, all you do is you write equals, and all of these circle numbers, okay, you just write it in a nice sentence and you multiply them by each other. So 5, so this one, times 2, so this one, times 5, this one, and times 2. So this is when you break down into into the product of primes. Okay, now another way, some of you may have realized this already, that we can write down 5 times 2 times 5 times 2 is 5 times 5. Another way I can say that is 5 squared. Same with 2 times 2, which is 2 squared. And because you're all multiplying them together, I can just say 5 squared times 2 squared is the same as 100. So if you just look at this, okay, break down into this product of primes, if I've done it correctly, this question over here should multiply or give me a product of this number over here. Okay, so if I've done it correctly. So 5 squared is 25, 2 squared is 4, 25 times 4 is 100. So I know I've done it correctly. Let's do another one. Let's do something slightly harder. Let's do 186, for example. Okay, so again, choose any two factors that multiply to give me 186. Now, if you can't think of a number, just try and half it. Okay, or try and divide it by 3, or any number that you can think of straight away. So 2 is probably the easiest one to start off with. So can I half 186? Yes, I can. It's an even number. So 2, which is a prime number, I can circle it straight away. And what's half of 186? Now, if you can't think of this off the top of your head, just think of it as what's half of 100, which is 50. What's half of 80, which is 40, and what's half of 6, which is 3. So all you're doing is you're just breaking down according to the place value of each of these numbers. So this is 100, this is a 10, this is a unit, and you're just halving each one, okay, to get the answer. So, and now you just add them up. 50 plus 40 is 90, 90 plus 3 is 93. Now, is 93 a prime number? Can I half it? Nope, because I can, but it will give me a decimal number, which I don't want. Can I divide it by 3? Possibly. Okay, actually I can. The way I know that is because 90 is in the 3 times table, okay, which is 30 times 3. So 93 must be 31 times 3. Are both of these prime number? 3 definitely is. And 31 is. 31, I cannot break it down any further. So 186 is 31 times 3 times 2. And there's no other way to write this down, so I leave it as 31 times 3 times 2. Okay, just one more thing. If I already know a prime factor decomposition, so for example, if I know that 20 is 10 times 2, 10 is 5 times 2 there, which is 5 times 2 times 2, or 5 times 2 squared. What about if I have the number 40? Do I have to actually go through this entire process of doing the factor tree and writing it as a product of its primes? No, actually. I can just use my answer from 20 and then apply it to 20 based on apply it to 40 rather, based on the relationship between the original value and 40. What does that mean? So 20 is half of 40. So to get from 20 to 40, I double it. So what would happen, do you think, to the prime factor decomposition, to the product of its primes? All you would have to do is double it. So 5 times 2 squared times an extra 2. So this extra 2 reflects that 40 is double 20. Okay. Also, I can simplify this further because 2 squared times 2 is actually 2 to the power of 3. Let's do this with one more example. If I know that 80 is 10 times 8, neither of these are primes, so let me break it down even further. 5 and 2 are primes, 8 is 4 and 2, 2 is a prime, and 4 is 2 and 2, both primes, so I've gone to that stage. So 80 is 5 times, and let me just write it down in index form. So write it down in power form straight away. How many 2's are there? So there's 1, 2, 3, 4 being multiplied. So 2 to the power of 4. So if I know that 80 is 5 times 2 to the power of 4, what do I think 320 would be? What's the relationship between 80 and 320? So 80 times something is 320. We know that that something is actually what? 4, right? So 80 times 4. So actually, if I wanted to work this out, 80, which I know can be broken down into 5 times 2 to the power of 4, I can just say, instead of doing the prime factor decomposition again, I can do 5 times 2 to the power of 4 times, and what is 4 as a power of 2? If I was to break down 4, it will be 2 squared. And hopefully you've realized that you can simplify this even more. This means 2 times 2 times 2 times 2. This means 2 times 2. So altogether, I can just say 5 times 2 to the power of number of 2's being multiplied, which is 5 times 2 to the power of 6.